and welcome to Lesson 3 of Unit 1 in Science. We're going to be talking about simple machines for this lesson. Now, as we get started, you're going to begin on your introductory pages. So you're going to begin completing page 36, and you're going to be deciding out of all of these pictures, you're going to look at different kinds of simple machines. People use different kinds of simple machines every day. Put an X in the box that are examples of using simple machines. Explain your thinking. How did you decide if something is a simple machine? You'll write your answer in the box and on the lines below, and you'll put an X or a check mark into the boxes above by the ones that you think are simple machines. After you've completed that, we're going to first take a look at some pictures of the cranes and the pulleys. So these are different kinds of simple machines. And then we're going to read about the construction manager for our STEM career connection. Once you've done that, you're going to write down your questions regarding the pictures of the cranes and the pulley that you saw. What do you think they're used for, and what questions do you have? Once you've finished reading the section about the construction manager, you're going to answer the questions on the following page. Number 1, what did the construction manager do after receiving the blueprints? Number 2, other than people, what else did the construction manager need to think about to get work done? And then your essential question, how do simple machines make work easier? Once you've finished up through page 38, we're going to go on and we're going to plan and carry out an investigation. And you are going to use a simple machine to lift objects. Now, your activity begins on page 39, and you are going to follow the directions here to build your simple machine. And first, you're going to make your predictions. Then you're going to set everything up according to the instructions on the pages. Then on page 40 is where you're going to start recording your data or your information. You're going to measure the different amounts of force that were needed to lift the blocks based on where you're positioning that marker underneath your ruler. So how many gram cubes did you need when you place it in the center of the ruler, when you place it closer to the gram cube cup, and when you had it closer to the block cup? After you've completed that, you're going to complete questions 1 through 3 on page 40. Now, our vocabulary words for lesson 3 are the words work, simple machines, load, wheel and axle, inclined plane, and compound machine. Work is what's done when a force changes an object's motion. A simple machine is a machine with few or no moving parts. A load is the object that's being moved by a machine. So the thing that you're lifting or moving or pushing is the load. A wheel and axle is a simple machine that's made up of a wheel stuck to a rod. An inclined plane is a simple machine with a flat slanted surface that's raised on one end. So think of like a ramp that they have next to stairs so that people with wheelchairs can move up and down. That is a kind of inclined plane. And your last vocabulary word was compound machine, which is 2 or more simple machines that are being used or put together. Now, for the next part, when we move into our pages, apologies, guys. When we move on to page 41, after we've reviewed all of our vocabulary, we're going to watch a video called Work and Simple Machines on the many machines that help us to do work. We're going to answer the questions after we finish. So for number 1, you need to draw an example of work that was done in the video. So any one of the examples that you're going to see. Then we're going to read in our science handbook. That's your textbook. We're going to read page 236, and we're going to answer the question, what is work? Then we're going to move on to the next page. We're going to try each action listed in the table. Is it work? Why or why not? So picking up a book, thinking about a problem, sliding a chair, pressing your feet against the floor, pushing against a wall. Decide, is it work, yes or no, and then answer why or why not. For number 4, what does a machine do? And what does a machine not do? So you have to answer both parts of that question. We'll then continue reading from page 237 to 242 to answer what are simple machines. Then we're going to fill in the table using the information from our science handbook or any other sources. And we're going to tell about each simple machine. So you're going to draw or write an example of each one in the boxes underneath. For number 7, you're going to pick one of the machines from the table that you just made. You're going to list which one it is on the line. And then look at the example. Explain how this machine makes work easier. So let's go watch the video first so that we can focus on the question on page 41.
What is work? Work can be easy, or hard, or fun. We use simple machines, like hammers, to build things, create meals, and entertain people. It takes work to fly us to faraway places. Work can move the earth and be good for the earth. In what ways will you work today?
So now that we've finished watching that video, we can go ahead and draw an example of one of the kinds of work that was done. And then we're going to go in and read in our science handbook. Now on page 236, our title is Simple Machines, Work and Machines. In science, the word work has a special meaning. Work is done when a force moves an object or changes an object's motion. For example, picking up a book is work. A force changes the book's motion. Pushing on a wall is not work. No matter how hard you push, the wall does not move. A machine is a tool that makes work easier. Machines do not change the amount of work that's done, they just change the way you do the work. For example, it's easier to move a heavy rock by rolling it in a wheelbarrow than it is to lift it and carry the rock with your hands. The wheelbarrow is a machine. Some machines help you use less force to do work. Other machines change the direction in which you push or pull. A backhoe makes moving dirt easier. A bottle opener is a machine that makes it easy to pry the bottle caps off of bottles. Not all machines are made of many parts, and some have a motor. Some are simple tools made of just one part. Now that we've completed the reading on page 236, we're going to go back and take a look at our question. What is work? You're going to find the answer to that right here in this first paragraph. Make sure you use a complete sentence when you're writing down your answer. For these next questions, you're going to decide based on what we read if something is work or it is not work. So remember, in order for it to be counted as work, you have to move an object or change its motion. Next, we're going to read page 237 to 242 once you've completed these questions. And we're going to answer these questions down here, starting from number 5. Types of simple machines. Simple machines are machines with few or no moving parts. There are 6 types of simple machines. They are the lever, the pulley, the wheel and axle, the inclined plane, the screw, and the wedge. Now, in these pictures below, you see examples of all of these things. So when you're trying to use the edge of a screwdriver to pry something open, you're using it as a lever. A pulley is something that helps you lift heavier objects. The wheel and axle is similar to what you have on your bicycles. The inclined plane is a ramp that's used instead of using steps. The screw is what you're seeing over here, where it has these edges all the way around it to help make that work easier. And a wedge is like an axe where it pries something apart. It pushes or cuts it apart into 2 different parts. Now we're going to read about each different kind of simple machine. Simple machines, lever. A bottle opener and a seesaw are both levers. A lever is a straight bar that moves on a fixed point. The fixed point is called the fulcrum. A lever can be used to lift something. The object lifted is called the load. In the diagram below, the girl is the load. When the boy presses down on one end of the lever, the load on the other end is lifted. The closer the fulcrum is to the load, the less force you need to lift the load. A crowbar is an example of a lever. Levers can make it easier for people to lift or pry objects. They can change how much force you need to move something. They can also change the direction of the force you use. Pressing down on a lever lifts up the load. Page 239, pulley. A simple machine that uses a rope and a wheel to lift an object is a pulley. The rope is looped around the wheel and tied to the object you want to lift. When you pull down on one end of the rope, the other end of the rope rises up. Like a lever, a pulley changes the direction of a force. With both a pulley and a lever, the force applied to one end makes the other end move in the opposite direction. The wheel of a pulley acts like the fulcrum of a lever. A pulley makes work easier. Lifting a heavy object directly can be very difficult. Using a pulley lets you use your body weight to help you pull the object. If the wheel is placed above you, the pulley also lets you lift the object higher than you can reach. Cranes use pulleys to lift heavy loads. So take a look at the two pictures over here. We have this seesaw over here that works as a lever. So we have the fulcrum, which is the thing that it tips on underneath. We learned that if the fulcrum is farther away or closer, it changes the amount of work you have to do to be able to move the object on the other side. A pulley also helps you to lift heavy objects by using your body weight to help you pull down on that rope. Once you're pulling on one side, the other side will be lifted up. Page 240, simple machines, wheel and axle. Another special kind of lever is a wheel and axle. It's made up of a wheel that moves around a post. The post is called an axle. Doorknobs and Ferris wheels are wheels and axles. A wheel and axle can make work easier to do. Turning a doorknob is easy. Turning a thin bar behind the knob, however, is hard. The doorknob is the wheel, and the thin bar is the axle. Turning the wheel requires less force than turning the axle. Did you know a doorknob uses the wheel to turn the axle? In a Ferris wheel, the axle is used to turn the large wheel. One of the tallest Ferris wheels in the world is the High Roller in Las Vegas, Nevada. Over 1,000 people can ride the Ferris wheel at the same time. Think about the amount of force it takes to move that wheel. Turning the wheel makes the axle of the doorknob turn. The axle makes a small movement, and the wheel makes the large movement. Next on page 241, we're going to talk about inclined planes. A simple machine with a flat slanted surface is an inclined plane. Inclined planes can make work easier to do. They reduce the force you need to move an object. Think about moving a heavy box onto a truck. You could not lift it off the ground to put it on the truck. You could slide it up an inclined plane instead. Sliding a box up an inclined plane requires less force than lifting the box straight up. An inclined plane wrapped into a spiral is a screw. It takes less force to turn the screw than it is to pound a nail. A screw changes the turning force into a force that pulls the screw into the material. It takes less force to push a box up a ramp than to lift it straight up. When you turn a light bulb, the screw end pulls the bulb into the socket. Word study. The word incline means to lean. The word plane means a flat surface. So an inclined plane is a flat surface that is leaning. So take a look at the pictures that we have here. Our inclined plane is like our ramp right here. It's easier to move this up a ramp than it is to try and lift it straight up in the air. And the bottom spirals on a light bulb or like the spirals we saw on the screws a few pages back. These edges that go all the way around the screw are what make it easier for you to turn that or tighten it into a piece of material rather than trying to hammer a nail in. Page 242, Simple Machines, Wedge. If you put two inclined planes back to back, you get a wedge. A wedge is a simple machine that pushes objects apart. It changes the direction of a force. For example, a wedge changes a downward force to a sideways force. The head of the axe is a wedge. The axe changes the downward force of the swing into a sideways force. The sideways force pushes or splits the wood apart. Most cutting tools, such as knives, are wedges. As you press a knife into food, the knife pushes the food apart into two pieces. A downward force on the axe pushes the wood left and right. Pushing down with a knife can cause it to push the tomato apart into slices. So let's go back and take a look at our questions. So now that we've read 237 to 242, we can complete the questions on this page, draw or write about different examples here, and answer question number 7. Next, we're going to take a look at page 243 in our handbook so that we can answer question number 8. How are compound and simple machines related? Draw a picture of a compound machine that you've used. Machines working together. Most of the tools you use every day are compound machines. A compound machine is two or more simple machines put together. A pair of scissors is a compound machine. Two wedges and two levers make it an excellent cutting tool. The point where they are joined is the fulcrum. When you push the handles together, the edges cut through the material. A can opener is also a compound machine. It contains a wedge, a lever, and a wheel and axle. Together, they act as one machine. Notice the labels on each compound machine. Each line points to a simple machine. Think about how these simple machines work together. So the edges of our scissor over here where the blades are wedges. And you know this because the part that's not sharp is a lot wider than the very sharp edge that does cut. The screw that holds your scissors together is the fulcrum, and the two handles where you put your fingers through are the levers. Now for your can opener, you have a wedge, which is the cutting part that cuts into the can. The wheel and axle is the part that you turn to get it to go around the can, and the handlebars are the levers. So for now, you can answer number 8, how are compound and simple machines related? And number 9, draw a picture of a compound machine that you have used. Once you've completed that, we're going to go in and we're going to have one more inquiry activity where you're going to build a simple machine. And this time you're going to have a different simple machine, or you're going to be using it a little bit differently. We're also going to be using what we call a spring scale for this one. And a spring scale is going to measure the amount of force that is needed to be able to lift or move an object. So you're going to make your prediction. Does a pulley make work easier? You're going to create your pulley with a partner. And then you're going to record your data. So lift the soda bottle without the pulley and with the pulley. Measure the force with the spring scale. Then you're going to complete the questions on the following page. Numbers 1, 2, and 3 on page 47. Once you've completed that, you're going to be done with this lesson. So we would have made it all the way through all of our inquiry activities. And then you'll come to the closing of the lesson.